little bit of a physics video. Yeah, I don't know exactly where I'm going to take this. I did have an obnoxious interaction with Pyrrho and Hythloday on this, whatever they do, this video thing. And my critique of them, is that both of them just drone on, and especially Pyrrho. Of just absolute nonsense. He starts talking about multi-dimensions, all this other crap. It's just, and then when they're critiquing my ideas, they're worried about things like what's the shape of a photon and, stuff that nobody is explaining the shape of photons, or, so it's just a waste of time. They're not interested in thinking about it. They're just interested in disposing of it. So exactly as I pointed out about Feynman, they don't care about the truth. They just want to believe their bullshit, and they're glued to this idea that it's a mystical and magical universe, and they're just not going to. They just don't want to hear that it's not. So anyway, I did think of a way of illustrating sort of a logical proof. That casts some light on the difference between Einstein and this theory, or even you could say it's sort of Newtonian, but no, Newton didn't go for it either, for whatever reason. I'm not sure what the reasons were, but anyway, yeah. But like I said, when it was first proposed as an idea of a particle gravity. It was proposed in an environment where they didn't have any model of the atom, and they didn't even know that light had a speed. So, you got to recognize that it's a different world. So, so Pyrrho brought this up, or Pyrrho I think did. Well, Hythloday complained about the inverse square law, which is the idea that, as you move away distance-wise, it's cube the distance, or however you want to look at it. But I mean, as you move away, there's a proportional relationship between the size of something, the amount of force it might have, and that's consistent with distance. So the closer you get, your force is cut in half by each doubling of distance. Your force is cut by a quarter. Whatever, the force is 1/4 for every half in distance. So as would be illustrated in Einstein's model. Well, first I'll get to the Hythloday point. So Hythloday brought up Mercury and the fact that its orbit isn't the same. Well, it's not exactly the inverse square law, that it's opposed to. It's opposed to Newton's laws of gravitation in terms of the creation of ellipses, because it's not a perfect ellipse. It's not a Newtonian ellipse, a perfect one. But again, it's off by 2 meters, per revolution or something, a tiny amount of distance when you consider the size of of the universe. I mean, of the solar system. So it's really kind of a silly thing to say it's not consistent with. Obviously, there's something else influencing it. And the influence is that, we don't live in a perfect solar system. The sun isn't perfect. None of these things are perfect. And those imperfections, those wobbles, those distortions will create subtle distortions in the rules. I mean, it's just not that complicated. In a perfect world, it would be perfect, but it's not a perfect world, obviously. But the rule is still consistent. So I just thought that was totally petty, that inverse square doesn't apply to gravitation because of Mercury. It's just an idiotic thing to say. Of course it does. So it's obviously somebody trying not to understand, not somebody trying to understand. So Einstein, did the curved space thing, and people think that it's just some simple thing where, okay, you take a mass and it just it just dimples space, and it just really simple thing like this, that you could just put you could take any fabric and put any weight on it, and you would end up with the right curve. Well, of course you won't. Einstein's fabric is a fabric of very specific tension. This tension can go in any shape. You know, he could have, if he had to, he could make it that, or he could make it this, and that's sort of probably more realistic. But to match the inverse square law, yeah, it's a very specific shape that the fabric's tension has to allow. So the mass is here, and it has to gradually, little, and then it really falls off as you go towards the end. So it's the amount of change in gravity is rapid here, and very, you know, it becomes irrelevant theoretically out to this distance. I mean, theoretically it would still exist, but it's so irrelevant that you can't notice it. But that's a very specific fabric, right? That's a fabric that has to have a perfect elastic tension all the way through it, and it has to match exactly that kind of elasticity. But clearly this bent space model could have fit any kind of gravitational arrangement. It wouldn't be inverse square. Inverse square is just one, and only one. Only one shape will match inverse square. Only one tension would work. And, you know, that's sort of coincidental, right? So understand that inverse square matches the shadows. It matches images. So if I have a pen, this is inverse square. As I move it closer, it'll get bigger proportional. And that's what gravity is doing, the same amount of thing. As the pen gets smaller, if you thought of it as being a gravitational object, as it gets smaller, it gets weaker. So it's exactly the same. And again, it's the same exact effect for magnetism and electricity in terms of their force laws. So doesn't it seem rather coincidental that the space fabric just happens to match when it could have been any tension of fabric? That the tension Einstein invented for the purpose? Of course he invented it for the purpose, and that's the whole point. He chose the space fabric with the proper tension to match the inverse square law. And but the one that really creates the inverse square law is this idea of a particle gravity. So again, let's go through this one more time, just because I do get comment from people that they don't quite understand. I mean, reasonable people. So if you have a force that's of photons, gravitons, and they're coming in all directions, all right? And so let's first understand how they got created. They're part of the Big Bang. Okay, there's a huge, as an explosion happens, if there's anything at all, any kind of thing that's not the tiniest thing, any grain of sand, it's why they make pipe bombs with metal around them, is to create pressure. You know, yeah, and it's the same idea for when the universe explodes. If there's any at the Big Bang, it wouldn't be a Big Bang if there wasn't some kind of crust on the Big Bang, something made it, some elemental element, some element that was too big to move fast enough, so it can't get out of the way. So as the Big Bang expands, there's pieces that are too big to get out of the way, and what they do is they create a pressure, because if it was all just sand or just something that was all the same and could move the same speed and all get out of the way at the same speed, there'd be no Big Bang. There'd just be a big whoosh, a big whistle or something. It would just everything would just whoosh all at the same speed and just disappear at the speed of light. But obviously something had to compress it, and so in that process, you could what happened was there's a ton of these photons that were created in the explosion are bouncing off that pressure. Essentially, they're bouncing off the bits that are moving too slow, and then they're bouncing into each other, and essentially creating a multi-directional field of photons. But there's a lot of ways you could explain the idea of just things. You could start off with a chaos universe right from the start. If I took a pool table and I took 100 pool balls, ping pong balls even, however you want to illustrate it, and they all had perpetual motion. That is, they all moved at the same speed, and they all moved just kept bouncing off the sides and bouncing off each other and always maintain the same speed, you can imagine that over time it would just all become chaos. It'd be, if you stood at any one place, you'd be hit from all directions by these balls. And that's basically what we have. We have this dense field of photons, and they've been bouncing, so to speak, and they're coming from all directions. So they're coming from underneath us, on top of us, around, all around us, and they're all moving in a straight line. So here's a body, and so you can think of it three-dimensionally. It would be a three-dimensional thing. And these photons moving in straight lines intersect with it. Now, because it's even pressure, there's just as much light coming from one side as the other, up, down, all these sides. It just sits there because there's an even pressure. But as soon as I split those two halves, oh, sorry, got to draw the picture where you're looking. Then what happens is the pressure is going to change, because now you have this place in the middle where, and let's understand, well, I'll show it in this illustration. And let's just say when the pressure goes in, it doesn't come out the same way it went in. So when it doesn't go right through you. But let's say even if it did go right through, you can see by having this opening that now there's opportunity for stuff to hit inside here, you know, where it couldn't before, and likewise for over here. So there would be now a new added place for there to be pressure coming from here and coming from here, and this side still has exactly the same pressure as it had before. The same universe is affecting this one. So like a ray, like a sun almost, the same rays are hitting this side as before. There's no new things coming over from this side, but as soon as I split these two apart, this side and this side are now getting hit. And the same would be true for the other side over here. But then if you imagine that these rays don't go through something straight, but they actually are deflected, okay, you could sort of appreciate that they go in coming this straight way, and then they go out at some angle. Alright, so think of it in the terms of them going out at all these different angles. That now when you separate these two things, there'll be a portion of this force that won't be hitting this thing because it's going out this way. So that if I separate these two things, they're going to end up getting pushed back together by gravity, because even though there is some force sweeping through these corners, the fact is all this force isn't on both bodies anymore, and it isn't even anymore. It's hitting this one here and it's hitting this one here, where before that was hitting the same body. So now they're hitting two separate bodies, and there's nothing to compensate, say, because this one isn't going right through to push this one here on this surface. It's deflecting. It might be hitting here, so I mean it's still going in, but I'm just saying there's more going out at some angle than it's going straight. It's not going straight across here. So in essence, these two bodies would be shielding each other from this external force moving this way. So that's the easiest way to see it, is if you can just understand the straight lines are coming out crooked, then you could understand that there's a loss of pressure here in this middle, and that the two things would end up getting forced back together. There'd be a pressure to move back towards each other. Now, I'm not saying it's an actual pressure, because I'm arguing that velocity, or the impetus to move, is something that's changed inside the matter. There's no exchange of energy, so it's not a literal pushing force. It's a exchange of directional information, as I call it. So let's do this kinetic thing, because that was Hythloday's problem. Apparently he doesn't understand kinetics. So apparently he has he has all these kinetic, he has the ball thing, where the balls bounce back and forth, and he has some other kinetic thing. He has all these kinetic toys, but he apparently doesn't understand kinetics. So the circumstance I'm arguing for these gravitons is they are indestructible. That means they can't be dented, they can't They can't push in and out. They can't flex. They can't do any of that stuff. They're made out of some indestructible material. Pieces of them can't break off. So their size can't change. Their shape substantially can't change, let's say. Their angle can change. You know, what side of them hits something could probably change. But that would be irrelevant in a kinetic circumstance. So, I'm trying to think of a way to... So anyway, so just understand, so their speed can't change. Their mass can't change. And they have no elasticity. They have no, they can't absorb something in some way. It wouldn't really matter anyway kinetically, because it would be an equal opposite reaction. If it were made out of rubber, it wouldn't matter. It'd still be kinetic. But anyway, so they can't exchange energy is the key thing. The only thing they can exchange is directional information. So if one's moving in one direction and it hits one moving in some other direction, they will kinetically react by exchanging a portion of their directional information. You know, this will go off, well, probably in this direction. No, this direction is correct. Well, it's maybe even straight. And this one will go off in this direction. So their lines will change by specific angles, proportional angles, and that's basically a kinetic interaction. Now, with things that can't impart energy, they can't break, they can't get bigger and smaller, can't slow down, it really doesn't matter what shape they are, because their energy, as soon as they come in contact with something else at any point on their surface, it's going to be their entire surface. It's going to, their center of gravity is going to be felt through that surface, because they're not springs, they're not flexible, they're not any of this stuff. They can't absorb and shoot off. But even if they could absorb and shoot off, like I said, it would happen so quickly that it's the same as a kinetic reaction, because the energy would be in them, not, they wouldn't be exchanging energy. They would only have their own energy. So it'd be like super balls bouncing off of each other. They're still very kinetic, right? They don't create any energy. You could throw them on a pool ball and have them bounce around forever too. And even though they would bounce faster, you know, because they can, than regular pool balls, in the end it's the same thing. But again, the rule is they don't change speed. Photons and gravitons don't change speed. So there's another fact that just seems a little coincidental, right? That gravity moves the same speed as light. Just a coincidence? I mean, all the speeds in the universe it could move, it just happens. It happens that the gravity, moves exactly the same speed as the photons do. And they're not the same thing. Yeah, I don't think so. I don't think it's a coincidence. Yeah, I think it's reason to take this investigation a little bit serious, that it might be quite possible that this stuff we call force in the world is really something real. It's made out of something. The something's moving the speed of light. Likewise, magnetism and electricity, the force fields of those two things move at the speed of light. The flux. I can't help you, cat. You've gotten food. Yeah, fuck you. You can complain if you want, but I'm not giving you more yet. Anyway, sorry, interruption. So yeah, I didn't do a great drawing of the kinetic thing, but I mean, it just seems like the argument Hythloday's making is how do they know, or why do they do this precise angular thing? How do they know which way to bounce off, so to speak? And that seems like a silly question when you think about the depth of physics and all the unanswered questions that would exist. Because it's like, what choice would there be? I mean, logically, something's moving at the speed of light, you know. So what if we have a circumstance where you have a circle and it's moving counterclockwise? So this one's moving away, this one's moving towards something. So what if I had something coming at this circumstance, and obviously it could never catch up to this one. So if this thing was moving at the speed of light and this thing's moving at the speed of light, it couldn't catch it going this way, right? Because it's going to be going faster than it, as fast as it is, and it could gain no ground on it. And likewise, when the two hit exactly here, there's zero change in the universe, right? One goes off this way and one just keeps doing what it was doing. And so that's not a coincidence, you know, again, I would argue. But I mean, that simple function kind of makes it clear that obviously this is the rule. This is why things move at a certain little angle in terms of these interactions, is because of the fundamental fact that there'd be no reason for something, when there's a head-on collision, there'd be no rational reason, all right, for one thing to just fly off that way and one thing to fly off that way, if they're moving at the same speed and they have the same mass. What would be the logic? Why would it? So why would your kinetic balls, when they swing back and forth, why would they just randomly try to go sideways? Yeah, they wouldn't. Just as a rule. I mean, a rather intuitively sensible rule anyway. No! Sorry, this cat is just so damn irritating. Yeah, so, I would really not have a pet by choice. Here. Ungrateful homeless bum. What do you call that? Squatter. He's freaking squatting in my house. And he wants rights. Yeah, squats in my house. And then decides to order me around. Rude little animal. Anyway, alright, so these are probably my worst ever drawings, but I just think the Einstein fact that, you know, think about it for a minute. Einstein's gravity could have been the idea of tension in the universe, and that's what it requires to create this bending fabric, is tension. His tension could be anything, and that wouldn't match inverse square. He had to choose a tension that matches inverse square. Where light already matches. And just trying to think if it would matter if light speed was any different, but I don't think it would change the inverse square law any. No, I mean, it's just the idea of the straight line movement that creates the inverse square. No, I mean, it's just, you know, straight lines and circles. This is inverse square as a function of straight lines and circles. You know, you just can't get around that. And, you know, it just seems kind of obvious that the straight line's being created by the photons, and the circles are being created by the trapped photons. No! Stop it! Go outside. Yeah, well, go out then. Fuck you. I'm sick of this fucking whining. Jesus. Yeah, animals. Go. No, he's not gonna go anywhere with this fucking snow and rain out there. Horrible. Hopefully the roof will stay on. Anyway, so there was something else I want to get to. I'm just thinking, you know, sorry, distracting. So it's been a pain, you know, it snows, the cat's a pain in the ass, because, you know, he doesn't want to go out and to go to the bathroom and all that shit, because I'm not going to give him a cat box. I refuse. Alright, so what other subject? Like I said, I know there was some other point I wanted to make. Damn. And I don't think it was I don't know if I want to do the polarization argument here. But again, let's just understand that magnetism and electricity match, and the only thing to really do is the nuclear forces, which are, you know, it's going to be a byproduct of these elements that I think we do know. So I mean, you got the the proton, the neutron, which I think is the key element, and the electron. And what's happening in their circumstance with gravity is, again, that gravity is made stronger or weaker. It's essentially focused by the idea of polarization, so that each one of these is more sensitive to the effects of the gravity depending on the polarization. So you could argue the photons are more sensitive to, you could say, horizontally polarized, and that the electrons are more sensitive to, well, it's vertically, horizontally polarized photons or gravitons. And the key thing is the neutron, because I think what the neutron is doing is it's actually creating so the proton is creating vertical, and the neutron is filtering horizontal. And the electron, so the electron ends up attracted to the proton, but ends up repelled by the neutron. Even though the neutron is neutral, it's still, the neutron can't be affected by either polarization. The neutron doesn't care about polarization. So that's sort of the key function here. But that's this whole idea of what goes in and what comes out. You know, that what affects something can be different than what they convert when it leaves them. So it's like food goes in and, you know, poo comes out. Something different than what went in can come out. And that's what can happen to gravitons when they interact with different pieces of matter. Is they go in one way, they come out another way, and that other way is has more effect on particularly different things. Oh yeah, it was the two-split experiment we wanted to get to. Oh yeah, so I'll play some of Pyrrho because I thought it was just kind of funny. Alright, so what else did I want to get to here? Yeah, so I got some work to do on this atom structure, but the point I'm making here is that this creates four essentially forces, right? There's this gravity of gravitons hitting all these particles, and that they're very small even compared to these particles. So there could be, you know, a graviton there could be 1,000,000 of them inside of an electron, let's say. And so this also gets back to the idea that, yeah, we have to really do the school of fish metaphor, and you have to really understand that there's a difference between the fish and the school of fish. So Pyrrho doesn't like this metaphor, but frankly it's a great metaphor for how these little tiny influences can change the big machine. You know, little tiny sardines go in and change a couple of fishes, and that little bit of change is enough to start the giant school moving. And that's sort of what happens. Alright, so what did I want to say here? Oh yeah, so the atom has these different forces in the sense that you have the idea of that the electron is being bombarded with heavier, you can almost say when they're polarized they're heavier, photons from the neutron, because that's the horizontal ones and the ones that mean something to it. So it has like a double line of force, and then there's a attraction force between protons and electrons created by the fact that they're of different polarity. So they have a force that's moving both of them towards each other, and then you have this neutron force away. And that's probably why neutrons and protons coexist, is because neutrons, although neutral, they must be producing as if they were, from the proton's perspective, they're not neutral. So it's what you might consider this to be is that there's it's almost like 220 voltage. You know, there's not a true neutral. What there are is the two extremes and something in the middle. So there's something with opposite polarity, 3/4 polarity, and then you know, completely horizontal polarity. And so that's a little different than calling something neutral, because it's not truly neutral. It's not no polarity. It's just neutral to the two others. Yeah. And the truth is that the neutron might be the true horizontal, and it's the electron that is the partial polarity. No one, your people probably aren't going to follow this. But so that would be the scenario is that the most extreme polarity is between the neutron and the proton, but there's still a polarity between the electron and the proton, and there's a repulsion between the neutron and the electron because they have a similar polarity, more similar than the proton and the electron. They're both negatively charged. One is more negative. Is that the way to say it? Sort of. See, the whole word charge kind of got ruined because, you know, there still is a direction. You know, it's not like negative charge is the same as positive charge. They're very different in the sense that one is an emitting force and one is a giving away something. So one's gaining something while one is losing something. And to just call them both charged just kind of sometimes I think gives the wrong impression. Yeah. So you could argue it's like the two poles of the magnet. It's not like they're just two separate poles. It's that, you know, one pole has the electron, is all kind of electron heavy. Well, that could be explained by them just having opposite directions. So they could be identical, it's just that they're flipped two different ways. So yeah, we better not touch that one because yeah, it's not the same as a current anyway. Alright, so we got enough of that. Alright, so let's do the two slit thing really quick. So the idea is that this two slit thing, so I thought of another problem with the two slit experiment. You know, the middle impediment, you know, and we've never really, no one ever talks about the aperture, which is a real problem because we don't know what the light that they're casting on this two slit experiment really looks like. We don't get to see pictures of it before it hits this thing. And the fact that it's going through this little aperture means that it's already being lensed before it even gets to the two slits. It's not a pure random blanket of light. It's already a lensed blanket of light. It already has a pattern on it in most two slit experiments. Okay, so we could say that these, you know, it's never really drawn the correct way, right? Because this middle thing is like 4 times smaller than the slits. So to really draw it realistically, you have to draw it in some sort of like small impediment, you know, because the slits are say 4 times, 5 times wider than the width of the little impediment. And so the theory is that two, like you know, the photon goes through both of these slits, creates a wave pattern, you know, two separate waves, and that the waves create the interference. Now, obviously, you know, in the Copenhagen interpretation is that this really happens. The waves actually go out, they cancel out on each other, they do all this crap, and then the photon is somehow floating around in nowhere land, and it ends up going where the probabilities dictates. And but clearly it's a wave that's created is the argument. Now you can't have it both ways. So I'm arguing it's diffraction. I'm arguing that no, the photon goes through one slit and diffracts off the material in a very precise, by a very precise angular amount, depending clearly on Feynman arguments about the distance, not only the thickness of the slit material. This thickness would probably be rather important. So I'm just saying my math is going to have the same variables: the width of the slits, the wavelength of the light, the thickness of the material, the distance to the targets. I mean, it's all the same variables. But I'm clearly just saying that what's going to decide this angle is going to be the point at which the light is refracted. You know, how deep into this field of electrons the photon travels before it hits an electron. So it just has to do about electron density, and that if it hits one later than sooner means that it will travel, it'll be diffracted by a greater percentage. And what I'm arguing is that the electrons are creating, this idea of a pattern because they have a probabilistic movement this way. So they're vibrating, and they vibrate at a specific speed, which means they spend most of their vibration time they don't have a consistent, they're not like here, here, and here. Their vibration is they spend more time in very specific locations, so it would be more like they can only be here or here, but they can't be any of these spaces in between, in the sense that they're moving very rapidly and have to stop and then move rapidly in the reverse direction. That's how they oscillate. They can't oscillate at one speed. They have to oscillate, okay, by going faster and then slowing down and then re-speeding up and then slowing down and then re-speeding up and then slowing down. It's that oscillation that's creating the pattern. Feynman uses the vector, idea of combining arrows. Put this arrow on top of this arrow and then do a hypotenuse to decide the probabilistic. So, the bigger the square, the higher the probability that something would end up in that location. And all that's really saying is that as you go more distance, okay, say with this clock idea, as you go around, that would be 1 second. Then 2 seconds would be another going around. So if something travels a little further, goes 1.5 seconds, the clock would end up here. This would be your vector, and its length can be variable. But you could see that if it's at exactly 6 o'clock to the 12 o'clock, when you put the two on top of each other, they would cancel each other out theoretically. So when they cancel each other out is when you have that zero probability. So that would be where the lines are in the pattern. Because there's an exact cancellation because the distance is exactly one cycle of the light away. And the whole point of the cycling thing is really specific to how light interacts with electrons at specific frequencies. But it clearly also has to do with the fact that there's going to be points in the vibration of the electrons where there's essentially the least chance of interaction. Something like that. But but the pattern's just built into the circle. So essentially the circle spinning, if you just thought of a ball on the string spinning, you could just think of it as, and it hit something as it spins. It thump, 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 thump. It's just the idea, this is creating your sine wave, is built into the idea of a circle that has some kind of occurrence. It could just go around and flip back and go around and flip back, but it's just, that's what's creating the wave. Alright, so we'll just play his little bit because what he says here just doesn't make any sense. Yeah, it just doesn't make any sense to me.
I'm saying there's no Heisenberg principle. I'm saying, so those are two pretty big ones right there, aren't they? That's a pretty big distinction, isn't it?
Yeah, see, he was just negating this whole thing, like, well, what's the difference? Who cares? Blah, 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 blah. Like, this is not a significant change that would have, I think, profound implications to, this sort of makes it possible. You could theoretically come up with the idea that, if you could actually control neutrons, it's difficult, right? They made bombs because of neutrons, but theoretically they might be gravity neutral, and so you could actually create some sort of anti-gravity mechanism by being shielded in neutrons.
But you're saying the same thing happens in the two-slit experiment.
Well, I'm saying that obviously the same thing happens, because I'm not saying the thing doesn't happen, but what I'm saying, it's being caused by diffraction. It's being caused by the vibration of electrons. Electrons are the moving part. The photon is trying to go from point A to point B in a straight line. The electron is changing its path.
So here's the bit. It's coming.
Well, I mean, I think that's standard physics, that it's the electrons on the edge of the materials in that slit that is bending the light.
So there. I mean, can you get more of a contradiction to that's exactly not the standard theory. That's not the Copenhagen interpretation. Again, there's no diffraction taking place. There is supposed to be the creation of two waves that the photon is riding on that interfere with each other. That creates the pattern. How can you not create the waves and then say that the waves are theoretically created? I'm just saying you're essentially negating the necessity to have any of these waves out here. So where's your wave probability bullshit? Why you just don't need it? It's unnecessary to the creation of the you don't need them to go through both slits. I'm just saying with diffraction, I don't need them to go through both slits. So how can you use diffraction as an explanation? I can create the slit pattern without going through both slits. You don't need to make you just need this. All you need is this triangle. Okay, you don't need a triangle made out of both, putting both of them together, saying they go to a location, creating a triangle, then bisecting that triangle at a 90-degree angle, and then taking the area of that. You don't need to do all that because it's all built into the electron. So if all the electron needs to do is move it here, any deflection is the deflection. You don't need more than one deflection to create the place it ends up. Obviously, when they're both end up in the same place, by doing the math with the triangle and creating, using the starting point of both photons going through, one photon going through both slits, you don't need to do that. I mean, you just need the one vector. So, I mean, it's kind of silly to say most physicists accept that it's electrons at the slits creating diffraction that creates the pattern. If they were saying that, then I wouldn't have a conflict with quantum mechanics.
Well, if that's standard physics, what do you need the wave function for?
Because the point is that it's bent at both slits, and there's one particle that only go through one slit.
That is completely unnecessary. If you're going to say the photons are being, that they're interacting with the electrons of the slits, you don't need to do the math with both slits. You have absolutely no need to do that. You can draw the same freaking pair. You can draw the same triangle to the target, get the same probabilistic answer without putting 2 points in on both slits. You don't need the 2 slits to create the...
Yeah, well, certainly understand that you do need the 2 slits, okay, for the density of the pattern. I mean, what the separations are going to be and exactly what the pattern will look like. But obviously, you can just do it with single photons going through individual slits. You don't need to have one photon go through both slits to do that. You just need single photons being diffracted by a certain angular amount based on how far they travel past this slit. And how, again, the wave function part, the amount of the diffraction, what percentage of diffraction there's going to be, is going to be dependent on the vibration of the electrons. How they're moving, their orbit, their cycle. You could say that even. You could just say the cycle of the orbit of the electron is what's really creating it. Doesn't really matter what mechanism you use. The point is that the destiny of the photon, where it's going to hit, is decided here. It's not decided anywhere else. This is the point where it's decided. I mean, in terms of the interaction that takes place. The photon travels from point A to point B. First it travels from the source. It is affected by the aperture, changes direction. It is affected by the slit, changes direction. This is how photons move. Straight line to a point where they're influenced by something. They're absorbed and readmitted. and that's the only way they function. Yeah, so that's enough of that. So I don't think there was anything else I had to say, except, you know, again with the school of fish argument, I'll just make it clear about this idea of you know, this energy transfer is just so simple. I mean, it's not. I mean, this direction transfer. So the argument being made is you have a school of fish and they're moving in different directions. Okay, I mean, well, you can see the idea of which way these fish are moving. And all that really happens is the graviton comes in and it hits one of these fish. Now, it could hit one going this way, it could hit one going that way, it could hit one going that way. The point is that this fish that hits this fish is going to change its direction off of this line. So it's obviously losing direction in this direction. And so it's going to leave going this way, let's say. And obviously what's imparting on this fish is direction in this direction. So it's giving it more orientation in the direction it came from. So that's how gravity works. It comes in and imparts directional information, leaves it a different direction, and the thing acquires the direction from where the gravity came from. So the gravity behind me coming through my back, okay, is coming out, say, my side. And what it's doing is it's pushing my back, not pushing, pushing is the wrong word again, it's orienting the fish inside of my back to tend to move more in this direction. That's what it gave to me. That's what it's giving to me. It's giving my back fish, they're slightly moving in this forward direction a little bit more. But at the same time, there's fish coming in the front, the same amount of fish, and they're doing exactly the same thing in this direction. So that's why I'm maintaining my position, is because the amount of fish hitting me through the back and coming out this side is the same as the amount of fish coming in this way and going out that side. So there's the same amount of directional information being exchanged currently, and that's why I stay in one position. And when I move, it's because there is a physical change of that directional information. There's more fish moving in that direction. Now, it's not when I move, when I do this, I'm not changing my gravity. My cells, my atoms, what's the word I'm looking for? My molecules are being changed, and their reorientation in a direction is pushing me. But they have to do it with real photons. They have to do it with energy. They can't just do it with gravity. They have to use energy to make it happen. So they have to release photons. They have to cause a chemical reaction that releases photons to be able to push my hand in a direction, which is different than gravity. That's a neutral force, where I have to take energy from the environment, put inside of me, and create gravity inside of myself to make my hand move. I have to generate some stored gravity, which would be the same as the photons inside of an electron, or the photons inside the atom. I have to release some of them and create synthetic gravity to make movement. Yeah, that's a pretty good explanation, I think. So anyway, generally speaking, we'll see where this goes. But I mean, I think obviously Hythloday and Pyrrho aren't going to give me a fair critique. They're just going to make petty arguments, and we'll see if that's quite useless. I think so. So yeah, I certainly can't count on them to provide anything useful, but they certainly haven't provided, obviously, a counter argument means anything. Hythloday's argument that he doesn't understand kinetics, well, I can't help you. If you don't understand that there's a system where, like your kinetic balls bouncing back and forth, where they can't change size, and you can't change their speed, and you can't change certain things about them, and that's why the same goes in as the same goes out. They exchange directional information because there's limitations on that system. Obviously, those aren't real kinetic balls, right? They're not perfectly kinetic. obviously what I'm arguing is the universe where it is perfectly kinetic. And so the only thing that can be exchanged is directional information, because size and mass and speed can't be changed. The only thing left is direction. Once you can't change speed and you can't change mass, the only thing left to change is direction. Can't understand that? Then I can't help you. Right. And yeah, and Pyrrho's just glued to his, you know, multiverse bullshit. And again, like I say, he's just illustrating exactly, he's proving my point. Because with the same glib dismissal that Feynman did to Lesage's theory, he's doing to mine. Same thing. He's proving in the same breath, you know, that you people aren't really, you don't care about the truth, and that you're basically just religious nuts. I'd say that Feynman was less of a religious nut, but he was still glued to his mathematical reality model, and he was also so arrogant that he basically just did think. If he can't think of it, nobody else can. And I think that's as simple as it was. He figured if he can't figure out how the thing works, then nobody else can, because he just thought that much of himself. Yeah. So anyway. But I will make you all eat something crow-like or shit-like. And I think you're jerks. Yeah, and I'm really going to enjoy it when I'm saying I told you so and such. Yeah. I hope to be a disgustingly bad winner. Yeah, I really do. It'll be fun. Anyway, till next time.